Hey Level 2s, and welcome back to 2.4 Atomic Structure and Bonding and Thermodynamics. This lesson is lesson 10, and our learning objective today is to use this equation here to calculate enthalpy changes of a reaction. So what I'd love you to do just as a starter task is please explain to me these two situations as to why they are exothermic or endothermic and why. So please pause the video, have a go, and I'll quickly go through the answer. So this first one here, this first reaction is exothermic due to the negative enthalpy. What this means is that more energy was released when making the bonds in the products than was absorbed to break the bonds in the reactants. This second problem here is a state change, okay, from solid to gas, which is sublimation. As the only thing that is happening in this, there is no new products form, it's just a state change. The only thing that is happening is the breaking of intermolecular forces from the solid to gas. Bond breaking requires energy, so this reaction would be endothermic. Okay, and there are the answers. Okay, so what we're going to do now is go through enthalpy equations, okay? And I'm going to show you, just going to scooch down, that's better. So here's an equation here, sodium hydroxide dissolving in water. So there's no water written here because aqueous means dissolved in water. So sodium hydroxide exists as a solid. So if I went to get some from my prep room, that's how it would be, a solid. And we dissolve it in water to make sodium hydroxide solution. You can see that this reaction is exothermic, so it releases heat energy, okay? And the other way of looking at this is, what does all this information actually mean? Because this is a 1 to 1 to 1 ratio, we could say that when 1 mole of sodium hydroxide dissolves, 20.2 kilojoules of heat is being released. So that's what we can take from that. We could also say that actually, because we know 1 mole equals 40 grams, and we know 1 mole because to calculate mass we do number of moles times molar mass. The molar mass of sodium is 23, approximately 16 and 1, so therefore the molar mass of sodium hydroxide is 40. 1 mole times 40 is 40 grams. So we could also actually say another piece which would be the same information is that when 40 grams of sodium hydroxide is put into water, 20.2 kilojoules of heat energy is released. So these are the two different ways we could actually explain what this equation is meaning. Now, the last thing that you should actually note is that we could actually include energy is actually part of the equation. So because this is exothermic and exothermic means energy is being released, then in this case energy would be written as a product. So you can see here how it's got, this is one product plus another product plus the energy. So if you ever see energy written as a product, you know that the reaction is exothermic, or if you see energy written as a reactant, it would mean it's endothermic. So what is the purpose of this slide? The purpose of this slide is simply to tell you when you get given an equation like this, what does it all actually mean and what are the different ways it can be represented? Okay. Just move this back up. So the next thing is that the amount of substance affects the energy released and absorbed. So it depends on, so how much you put into a volume of water will affect how much energy is released or absorbed, and that makes sense. So for instance, if we put 1 gram of sodium hydroxide in 40 mils of water, 504 joules of energy is released. Okay, so when 1 gram is put in 40 mils of water, 504 joules of energy released, and we actually see a temperature rise of 3 degrees. If we put that same mass of sodium hydroxide in half the amount of water, then that means that the temperature rise is going to be more significant. We're going to see a temperature rise of 6 because there's less water for that reaction to dissipate the heat to. Again, if we doubled the amount of sodium hydroxide as in the first one with the same amount of water, then we're going to see double the temperature rise. So this stuff is all important and significant when we look at these problems. So that's the first thing to note. Okay, so here's during this lesson, we're going to go through a bunch of thermochemical equation examples, and I'm going to show you how to do them. They take a bit of practice, and we're spending all of next lesson on this as well. So here's the first equation. When carbon is burnt in oxygen, carbon monoxide is produced, and this reaction is exothermic, which we can see from that negative sign. The question says, find the heat released when 10 moles of carbon react. Well, in the equation, you can see that 2 moles reacting releases this negative 230. So if we want 10 moles, then we need to times this by 5. So if we go 5 times negative 230, we will see that it would be negative 1,150 kilojoules per mole. Hopefully that makes sense. Part B of the question says, find the heat energy released when 6 moles of oxygen react. Well, in the equation, this is a 2-to-1 ratio. So 1 mole of oxygen releases negative 230 kilojoules per mole. So if we're looking for 6 moles, we need to times this by 6 to get negative 1380 kilojoules per mole. So what I'm trying to show here is that if they ask you a question about how many moles would produce this amount of energy, you need to look at your molar ratio of your equation that is standing and manipulate from there. It's the easiest type of calculation. Okay, so example 2. Okay, this one here is where you've got sulfur dioxide reacting with oxygen to produce sulfur trioxide. Again, it's exothermic because of that negative delta. Okay, so here they're saying if, well, I've just said there, and it says if 1 mole of SO2 reacts, okay, how much energy would be released? Well, in this example, if 2 moles produces this amount of energy, then 1 mole would produce half the amount, okay? So it would be 94 kilojoules released. Hope that makes sense. Oops. So thermochemical example 3. We're getting a bit harder now. Instead of just asking you about moles, I'm going to ask you about mass. Now we know from topic 1, 2.1, you can never relate mass, you can only relate moles. So what we must do to do this question is we must turn all masses into number of moles. And we turn all masses into number of moles through this equation. Okay, so let's look at the question. How much energy is released when 3 grams of sodium hydroxide is dissolved? When we dissolve sodium hydroxide, this is the equation, and this is how much energy is released. They would have to give you that. So from here is our answer. So we first need to turn our mass into a number of moles by doing mass divided by molar mass. Remember, you can always calculate the molar mass from your periodic table by adding up the masses of the individual elements. 23, 16, and 1 make 40. That means that 3 grams is actually 0.075 moles. We know from the equation that 1 mole releases negative 20.2. So therefore, if we take our 20.2 and times it by 0.075, that'll tell us how much energy is released with our 3 grams. And so the answer is 1.52 kilojoules per mole. Let's have another go. Again, we're using sodium hydroxide as an example, but this time I'm asking you when 12 grams of sodium hydroxide is dissolved. Remember, we can never relate mass, we can only relate moles, so we're first going to turn that into a number of moles. So number of moles is mass divided by molar mass, so 12 divided by 40 is 0.3 moles. We know that this is 1 mole producing negative 20, so therefore if we've got 0.3, we just times it to the energy, and the answer is 6.06 kilojoules of energy. Just be mindful, the question actually said calculate the amount of energy released. So we don't actually need to put the negative here because they've said energy released. If you did put the negative here, you wouldn't be marked down. It's not just kind of a bit of a trivial thing for this part. Okay. So here's another example, example 5. I said we're just going to do a bunch of these today. So this one here says calculate the mass of octane needed to burn to release 10,000 kilojoules of energy. So a little bit harder, this one actually. So here's the equation where we have 1 mole to 12.5 moles to 8 moles to 9 moles, and this amount of energy is released. So what we need to look at here is what's really going on. And so if we have 1 mole producing negative 5470 kilojoules, okay, then we need to know, well, how many moles is producing that would produce 10,000 kilojoules of energy? So what we need to do is do 10,000 divided by 5,470, okay? And what that will do is tell us how many moles, because if 1 mole produced this amount of energy, then if we've got this energy and we divide it by this energy, it'll tell us how many moles that would be. And the answer is 1.83. So if we know the number of moles, then we can times it by the molar mass to work out the mass. So this is all kind of like mathy type ones where you have to be a little bit logical about what's going on. So that's pretty much it for these. You basically just need to go through and do a ton of problems. And over today's lesson, you're going to be doing this enthalpy worksheet. The study guide activity is an optional one, but I do recommend doing it to have a go. But yeah, just follow the plan on the OneNote, and we just need loads and loads of practice. Okay, thanks team.